In this video, we're going to look at a problem on geometric series, such that we are given a geometric series, which is given by 16 plus 20 plus 25 plus so on. We want to find the least number of terms required to give a sum greater than 2,500. So let's list our key information then. We've got our first term, which is A, which is 16. We can find our common ratio R by doing the second term divided by the first term, so 20 over 16, which simplifies to 5 over 4. We don't know what our n is, we need to find that, but we do know that the sum needs to be greater than 2,500. So that's the key information we've got. Now we're going to use this to get a value for n. So we need to use the summation formula, and we can substitute into that. So we have our a, which is 16, times 1 minus our r, which is 5 over 4 to the power of n, all over 1 minus our r, which is 5 over 4, which is greater than 2,500. 1 minus 5 over 4 minus a quarter times the 16 becomes 16 divided by minus a quarter becomes minus 64. So you've got minus 64 times 1 minus 5 over 4 to the n is greater than 2,500. Now we can get rid of the minus by flipping those two, so we can say that really we've got 64 times 5 over 4 to the n minus 1 is greater than 2,500. Means that we don't have to worry about the inequality sign there. So let's divide by the 64. So we've got 5 over 4 to the n minus 1 is greater than 2,500 divided by 64 gets us 3,125 over 8. Moving the 1 over becomes a plus 1. So you've got 5 over 4 to the n is greater than 3,133 over 8. At this stage, to deal with the power, we need to bring in logarithms to both sides. So let's use the natural logarithm. So natural logarithm of 5 over 4 to the n is greater than the natural logarithm of 3,133 over 8. Bring the power to the front as a multiplier, so n times the natural logarithm of 5 over 4 is greater than the natural logarithm of 3,133 over 8. Divide by the natural logarithm of 5 over 4, such that n is greater than the natural logarithm of 3,133 over 8, all divided by the natural logarithm of 5 over 4. We don't need to worry about the sign on the inequality because the natural logarithm of 5 over 4 is a positive value. Now, that's not very helpful to us, so let's convert that into a decimal. So we've got that n is approximately greater than 26.755 and so on. So therefore, as n must be an integer value, a positive integer, and satisfying this inequality, n is going to equal to 27. So just to tidy it up with, as the question asks, the least number of terms is 27. And that's where we'd finish this question. Now, like the last one, as I explained, depending on what they ask, you might need to substitute this into the nth term formula to get a value for that term, but this one specifically asks for the number of terms. So 27 is where we finish.